For example, we learned with some French clients that the text to speech model, the actual synthetic voice, it needs to be a lot faster, like the cadence. It needs to speak faster to be more natural. And we need to interrupt over a longer time span. Whereas some cultural norms are a little bit different. Hi, everyone. Welcome back to another episode of Deep Learning with PolyAI. My name is Megan Berton, and I'm one of the group product managers here at PolyAI, working on some of our technical products and machine learning models. And I'm here with Razvan. Would you like to introduce yourself?
I'm sure. Hi, everyone. My name is Razvan. I'm a VP of engineering at PolyAI. Been with the company for quite a long time. I think it's close to being 7 years now. Yeah,
Ancient, just like
ancient, a
owls.
dinosaur. Yeah.
Uh, we're here actually to talk about OWL, which is our automatic speech recognition model. Uh, Tell us a little bit about how we named it OWL. Could you maybe sort of prep the audience or prime the audience with what speech recognition models are, a little bit about how they work?
Cool. I guess, yeah, I guess I'll start with the speech recognition part. So as we
Mm.
build voice assistants, a natural first step to, ingesting the audio, the normal conversation that happens over phone is to transcribe it into text. So turning audio into text, that's what speech recognition is. I mean, in a nutshell, obviously understanding when a human's speaking and when they're not, which of the participants is speaking at a time, which is called diarization, um, and just transcribing accurately, representing the words into text as accurately as possible. Now that'd be owl. That's a fun name. We were keeping a bit of a bird theme going on with our releases now for all these foundational models. I think that started pretty early on in Poly AI. I think most of
Mhm.
our projects were named with birds. We had finch, we had we had peacock, we had swan. Talking about our first voice agents in different sectors. So I think it's quite a nice going back to our roots. Yeah, it's quite funny seeing like the
Keeping the
bird theme does.
tradition alive.
Yeah, for sure. The bird theme does come up a lot in the industry. Actually, we saw that NVIDIA's models are also a version with birds. So it's I feel like a lot of people are on the same page here, just like birds.
Mhm. So I want to touch on a little bit more on how speech recognition models work to give a little bit more context. So you mentioned like this is the first piece of the tech stack. Conversational AI assistants, they can only respond, their output can only be as good as sort of the input they're receiving. So my assumption would be, well, I guess I know because we work on the same team, but there's a lot of challenges with these models. Like it's a very tricky problem to solve. Could you maybe explain a little bit about why this is such a hard problem to solve?
Yeah, for sure. I think the problem comes from many different facets here. I think when you're building a conversational assistant, the first thing you might think about is latency and naturalness and responsiveness and stuff like that. For that purpose, you'd need quite a small model, and so you can't use a huge model and a huge GPU with billions and billions of parameters. Just this is going to be too slow. We have very uh, we cover a lot of area in terms of use case and geography. So there's many accents, there's many speech patterns. The hardware is different. Phone lines are extremely noisy. We have use cases when people talk directly to kiosks, for example. There might be a car engine in the background. People want to be calling from the
Someone's
roadside and might
television
have
in the
bad reception.
background.
Yeah, absolutely. And it's just I think that's just one of the reasons for this being a tricky problem. And then obviously the important part, which is the aspect of form filling that we do, collecting names, addresses, so we can actually execute a business logic on behalf of our users. Accuracy is paramount. A digit off can break a whole address. A digit in a postcode, breaks the whole identity of that person, so they can't get on with their requirement as well. Yeah.
So performance, latency, interruptions, background noise, accents, and many more things. How does having an in-house model, our OWL model, how does that set us up to have improved performance and to do better on these things than if we were to just adopt third-party models?
Yeah, for sure. Having an in-house model has really changed the game for us, and I think that's where our partnership with NVIDIA has come up, and we've been able to deploy these models on NVIDIA Riva, and we have access to these super state-of-the-art models that we can fine-tune ourselves. I think this is
Mhm.
where having an in-house model really shines when you first of all, we can guarantee to our users that our versions are fixed. With third-party APIs, they can change the version at any time. They can break a whole piece of the business logic. If I don't know, certain words all of a sudden stops being transcribed, like that company's name, that, and then you break their whole use case. So we have this very good versioning that is probably not as interesting, but it's really something that keeps coming up again and again. And we've really gotten rid of that issue with having an in-house model. Second of all, it really helps for compliance. So again, keeping our customer data safe. We don't need to send our data to third-party providers to fine-tune. We can do that in-house. The data never leaves our environment, so it's safe and very good for compliance. And keeping all the
Latency.
PI in one place. Yeah, and lastly, lastly, I was going to mention latency as well. You're not going over to a different cloud provider that might have God knows how many hops before you get to the actual servers. So we can optimize this infrastructure in a way that really shines in a natural conversation with our agent.
And so maybe something that would be helpful to give more insight into is how we improve performance of our in-house model, particularly because, our client base stretches across so many different regions, accents, languages. Like, how do we approach fine tuning and improving the model so that we can do better on these specific use cases?
Yeah, for sure. I think what's become very apparent in the last few years in the machine learning front is that data is king, and data is the most important part of your sort of machine learning improvement lifecycle. You need to have data that really targets the exact distribution of what people might be talking about in these phone calls. That's why it's really important that we can use our already existing data that we've collected from our live conversations to fine tune. That definitely boosts our performance substantially. Um, then again, with audio, getting high quality data is quite tricky. You need to in order to train these machine learning models, you need um, annotated data. So that means pairs of the audio and what was actually said in that audio. And if you could automate that, then our problem is solved. You usually need a human in the loop here to make sure that data is transcribed correctly. And that obviously becomes an operational challenge when you have multiple languages and multiple accents as well.
Yeah.
So in order to
I'm sure.
also, yeah, no?
No, I was going to say, I'm sure our machine learning team would be very happy if we could automate some of this annotation. I think we annotate
Yeah,
so
for sure.
much data that. Mhm.
For sure, we do need to annotate that data for improvement and for evaluation as well.
Mhm.
And in order to really like make a dent here, we need to get a bit more creative with how we source this data. So I think as far as also one thing that I forgot to mention is the type of data that we can actually train on. We're really reluctant to use PI in this training data just because that might put our users at risk. So we avoid that, and therefore we need samples that represent addresses, names, unique identifiers like tracking numbers, driver's license numbers, and so on. So in order to do that, we leverage quite a bit of synthetic data generation. So that means
Mm.
that we can we take the text and we use one of the existing or text to speech models. So the opposite problem of turning text into speech, and we can generate data set that way. So and I'm sure you're all familiar with this new technology. So you ask ChatGPT, hey, generate 100 ways in which you can say a random name from this region, and then pipe all those responses back into a text to speech model, and there's all annotated data. So we go around it the other way around. Another really important tool here is distillation. So like I said, for our live traffic, our models need to be very nimble and swift, like owls. But for annotating data, we can use some huge dinosaur birds here.
A
The
pterodactyl.
a pterodactyl, exactly. So
Tyrannosaurus
that we
Rex.
I think we've had quite a bit of success with Canary, actually, which is the NVIDIA Riva model that we use for this
Okay.
purpose. It's pretty slow. Latencies are seconds in magnitude here, but we can get huge huge samples of conversations, pass them into this bigger model. It's not going to be perfect, but it will be better than the smaller model. So we can use this data to further improve it. And then we're always on the lookout for open source data sets as well that might match our use case as well. That's the most important thing, is having a good data set. And I think so far I've only been talking about training. Evaluations always I think the trickier challenge here. As you release new models, and especially in our multi-tenanted architecture, it's really difficult to bias the evaluation set in the wrong way. So say if you have a bigger client and a smaller client, and you have more evaluation points for the bigger client, then you might not see a regression for the smaller client. That's why it's really important to have a very good biased evaluation set. I've mentioned the client sort of dimension here, but we're also talking about extracting names, extracting addresses, all these smaller tasks that are implicit in the model. Say if you're only training on address data, you might get worse at send data and so on.
So you've mentioned a lot of different ways that we aggregate and pull data for evaluations and then also for fine tuning. I'm curious if we could go a little bit more into the synthetic data side. You mentioned something about having a broad distribution of data. Are we talking about a distribution of data on the text side we're synthetically generating and also the audio side? Because I would assume with text, we want lots of different ways people can say things, lots of different words. But then on the audio side, we also want to capture accents and different ways people say things. So could you explain a little bit more about how we're curating a data set with synthetic data? Why is that better than just doing the annotations ourselves, or how is it different?
That's a really good question. I think that makes it the distribution of text. I think that's an easier problem to solve. For example, we can
Right.
see which particular terms our clients are unhappy about because they can annotate them on Agent Studio, and then we can generate text
Agent
that's
Studio is
similar
our
to that.
platform.
Yeah. Thanks for that for you guys again, though. And since users can interact with the conversation history, and they can be like, this turn is bad, this turn is bad, we can see where that turn happens in the conversation. We can generate turns like that, and all of a sudden we have a surgically designed data set that will improve
So it's
performance in
very
that particular
targeted.
very targeted. Yeah, exactly. And if you do that over and over again, you're gonna even out the surface of where your model performs over time. On the audio front, I think that becomes much trickier with synthetic data in particular. Already, all these platforms that provide text-to-speech services allow sort of zero-shot cloning. So you can provide a snippet of a certain type of speech, and then it will try to clone something that sounds similar to that. That's a way in which you can generate different accents. I don't think we've had great results with that. However, what really did improve our performance is adding background noise, adding TVs, adding crying children in the background, and all these techniques to from one single sample you can generate 10 or more of, here's a sample with a car engine in the background, here's a windy sample, and so on, and that really creates some sort of resilience to these external environmental factors.
And that's another
That's
benefit
really important.
of being able to have our models in-house, right? Because third-party models, they're not actually fine-tuned or improved to take these different things into account. There's lots of different use cases for speech recognition models. Conversational AI is pretty unique in what it needs.
Yeah, for sure. I think if you start playing around with third-party providers, you'll see that the use cases are so broad. Like YouTube needs a speech recognition model to display
Audiobooks.
captions, audiobooks, yes, and so on. There's so many use cases. I think this really breaks a bit when you get really into latency, interruption rates, and dealing with the real-time use case. And there's a lot of trade-offs we need to make with these models, which I don't think you can get the same level of faithfulness to what a human-like conversation looks like with off-the-shelf models.
Could you explain a little bit about this trade-off and help us understand why this trade-off is so tricky between interruption rate and latency for these models?
Yeah, for sure. I think when you talk to someone, and especially face to face, there's so many signals the two parties give each other. Now it's my turn to speak. Now I'm signaling that it's your turn to speak. You might say, yeah, I'm following you. You might give me an encouragement to continue speaking. And I
I
think
might
these phenomena,
scoff and give
you
you
might,
disencouragement.
yeah, and
Is
in
that a
which
word?
case I know too. Yeah, I think so. Yeah, just encouragement. Discouragement.
Keep going. Sorry.
Yeah. You might, I think we've just done this
It
volley
is.
now. I think it's a very good example of people know exactly when to interrupt each other, when it's polite to do so. The model does not have the same sort of social cultural awareness. So what usually happens in these models, there's a window of silence, which we refer to as their VAD window, a voice activity detection window, in which the model waits for a certain number of milliseconds for silence before it actually processes the speech. When you're building this ensemble of, here's the speech to text model, then there's an LLM model, which are also quite expensive. Then there's all these expensive in terms of latency. I mean, then there's all these other functions they need to run, like an API request to update a booking and so on. And on the background, this might actually increase your perceived latency. So how much a user actually waits before they hear something back from the agent. Yeah, that's why it's quite a tricky balance here to figure out when a user is done talking versus when a user might say something in their thinking. Say you've asked them for an ID number. They need to be like, hang on a sec, I'm just checking. I just need to take it out of my wallet and read it out to you. So all these nuances of how people interact, I think we've seen experimentally, they kind of lead themselves to be on a curve. If you map an interaction rate and latency, from what we've seen, is if your model is very, very snappy and it cuts users off, then you have a high interruption rate. And on the other side, you can be
Right.
very lenient, but then the user's like, hey, are you still here? Like, are you still talking to me? On the other hand, so I think that's
Yeah.
that's a very interesting curve that we track all the time. Now we're obviously trying to minimize both, but we found that there's a trade-off. There's a trade-off to be made. And I think the industry is not serve, like, I don't think this is a solved problem. And there's no API out there that says that says conversational GAD turn on in all of these providers. I don't think that's a thing yet. So I'm quite excited to see how we're gonna progress with this. There's loads of innovative ways we've been doing. So like we've been using, so say a user speaks for a bit, and we just start processing that partial response. And if they decide to continue speaking, then we turn it. But if they don't, we have something ready to say. So we cut latency that way. We're also very excited about the future with audio LMs and what they allow, where you can actually use maybe integrate this, like, cultural element of how people interact that's encoded in the large language model.
Be a lot more contextual. I like what you
Yeah.
said, calling out a little bit like the cultural differences. For example, we learned with some French clients that the text to speech model, the actual synthetic voice, it needs to be a lot faster. Like the cadence, it needs to speak faster to be more natural. And we need to interrupt over a longer time span. Whereas some cultural norms are a little bit different. So I think there's this balance of we want to improve all these models generally, but we also have analytics and we have to make project specific and client specific changes and implementations, which is nice as well. Can you talk about a bit how we balance general model improvements versus what we're doing to sort of make sure every model is the best for the individual clients, particularly speaking to L and ASR, like the project specific piece?
Yeah, sure. I think again, it's a combination of many factors that I think we've touched on before. So it's building a strong evaluation data set, building a good
Mhm.
fine-tunable data set, um, and then targeting those areas that really need our attention by using client feedback on LB Agent Studio. I think those are I think critical. But also having the eye open, looking at what new models come up, how we can leverage them, what new solutions are there. Like I mentioned, audio LLMs. Um, so LLMs that take audio as input, they can have huge performance boost for us. However, they're too slow at the moment. But I think our colleague
Really
Matt Henderson posted on LinkedIn a while back a graph showing the
a
difference
good
between Whisper
plug.
and GPT. Yeah, and I'm sure he's happy about the plug. Um, yeah, I mean, what's really helping us here is our partnership with NVIDIA as well. We have access to their latest, greatest models and their inference servers that really allows us to scale this process. I hope I answered your question here. I'm not sure
You
if I covered
did,
what you
you
wanted.
did.
Yeah.
Yeah, no, that was a great response. I think it's something as well, which is I think where like the managed service piece comes in and how we sort of work with our clients in partnership is it's not just improving things across the board or why you'd like look at the ASR Hugging Face leaderboard and see the best models. It's also about making sure we're doing all these best implementations for our clients. And the tech stack is actually quite complex, like VAD, all these different things you mentioned, they all add up together. And so we have to make sure it works best for clients. So I don't want to steal the final wrap, but how should we close this wonderful episode of the Deep Learning Podcast? You've mentioned a lot of reasons why our in house investment in speech recognition is really amazing for clients. Is there anything you want to add or emphasize, or is there anything you want to say as we close about looking ahead towards the future?
Well, I think the our samples on our website, I guess, speak for themselves, and like how far we've gone on this on this journey of like improving the naturalness and accuracy of conversations. And stay tuned. Like I hope we're gonna be able to post way more graphs showing how Owl's performing better than similar technologies out there from other vendors, and why the data that we have in house is so valuable for this use case. And yeah, we're really excited about, again, like I said, about future technologies, integrating audio LMs into our tech stack as well. It's definitely something that we're actively looking at.
Amazing. It was such a pleasure to speak with you.
Yeah,
Um,
always a
and
pleasure.
hopefully Hopefully everyone enjoyed the episode. And I have to close with our team is hiring. Apologies if I'm not supposed to plug that, but follow Razvan because the team is hiring. And if you want to work on some of these problems, we want to work with you too.
Yeah, for sure. And we're looking to grow the team. This is
Mhm.
this is quite an exciting time to be building these components. So yeah, please join the team. Can't wait to have you here.
Okay, thank you everyone. Bye.
Thank you. Bye.